You do whatever you want. All right, YouTube Nation, we are going to look at ellipses today. Ellipses, 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 okay? Ooh, I'm sorry about that. And I will tell you that today's lesson is going to be easier than yesterday's lesson. How does that sound? All right, here we go. An equation for an ellipse, x minus h quantity squared plus y minus k quantity squared. That looks like the equation for a circle, but it's over a squared and over b squared, and it's equal to 1. That'll be the equation for an ellipse that's stretched horizontally. Equation for an ellipse that's stretched horizontally, okay? The center of the ellipse is HK. HK. Is everybody good with that? The vertices are the points that are stretched furthest from the center. And here's the cool thing. The number of units that it's stretched in the horizontal direction is not a squared, but rather just a. So when we move a units from the center, think of the center as having an h value and a k value. If we move a units horizontally, is that going to change the h value or the k value? H. So you have h plus or minus a, and then you have your k value. The length of the major axis, okay? The length of the major axis. The major axis is the distance from here to here. What do you think it is? 2a. Can anybody guess how far it's stretched in the y direction? B. So if you move b units in each direction, up and down, that will allow you to create the minor axis. Anybody want to guess what the length of the minor axis is? 2b. Every year in every class, when I say the 2b, somebody follows up with, or not to be. It does. The foci. The foci, if you remember in parabolas, we had one focus point, but in ellipses, we have 2 of them. And the foci sit c units from the center. So that's going to affect the h value. So it's h plus or minus c, and then k. There should be a question that's coming to people's mind. How do we find c? We have a formula for c. Hint, it involves a squared and b squared. Minus. It's like the Pythagorean theorem, except it's minus instead of plus. And because a squared minus b squared, a squared would need to be larger than b squared in order for it to be positive. So we say that a squared is the bigger of the 2 values. And we will reference that in a second here. Finally, eccentricity. Eccentricity is the measure of how stretched the ellipse is. So you could have an ellipse that is basically just like a almost just like a circle, right? Or you could have one that's really, really stretched out like so, right? And so eccentricity is the C value divided by the A value. And here's what happens. If you come out with a value close to 1, it would make a line. If you come out with a value close to 0, it would make just a circle. Okay. The Dementos. All right. Now, what we're going to do is we are going to look at a vertical ellipse. Here's the difference between a vertical ellipse and a horizontal ellipse. The vertical ellipse has x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. What changes? Yeah, a squared is always the larger of the two values. So if the larger of the two values sits under y, then it's stretched vertically. If the larger of the two values sits under x, then it's stretched horizontally. Okay? So think about this as my center is HK. Start to think about this. How many units am I stretched vertically? A, because a squared sits under y. Very good. Way to go, Mad Dog. How many units do you think is stretched horizontally? Y. How come? Yep, B sits underneath the x values. So the vertices are they going to be on the top and bottom or side to side? Top and bottom. That's where it's stretched the most. So that's going to change the y value. So it's h, and then it's k plus or minus a. The length of the major axis. 2a. Major axis is the larger stretch. Minor axis. 2b. And the foci, this time, they sit along the major axis, so in the vertical direction, they are stretched. And it would simply be h and then k plus or minus c. Well, focus, it's kind of like an octopus or octopi. Fungus, fungi. Not like I'm a fungi. Oh, jeez. Oh, my goodness. Emma, please come on up and share with YouTube your joke. Bring the microphone to you. Okay, Emma's got a joke for y'all. Here you go.
Are you a mushroom? Because you're a fun guy.
Wow. It's amazing. All right, I apologize, YouTube. We are at 5th hour, and the guys are hanging in there. The girls are definitely falling apart here, so we're going to try to keep it together. Are you a mushroom? Because you sure are a fun guy. Yeah, funny, huh? Here we go. All right, so we're going to sketch our first ellipse, and we're going to label these important characteristics: center, vertices, major axis, minor axis, foci, and eccentricity. The first thing that we do is, as we look at it, we identify where it's centered. Anybody determine where this is centered? Zero, zero. Parth, how many units is it stretched horizontally? 2. How many units does it stretch vertically? So we have 2 units horizontally in each direction, and we have 5 units vertically in each direction, because the 25 is under the y, and the 4 is under the x. And as soon as I do that, that's enough information to sketch the graph. And now I can walk around and see how horrible your ellipses actually are. Because most people do not do a very good job of drawing these. I would rate mine at about a C minus. All right. Well, maybe you guys should get up and teach a class then, huh? Okay. All right. Very good. All right. Some of you are very humbled by the process. So, you tell me, what are the location? What's the location of the vertices? 0, 5 and 0, negative 5. So 0 plus or minus 5. What is the length of the major axis? 10. What's the length of the minor axis? 4. In order to find the foci and the eccentricity, what value do I need to determine? C. I take a squared, or 25, minus b squared, which is 4, and I get 21. So C is the root of 21. The root of 21. All right, so I have this root of 21. Now what to do with it? Well, the foci are going to move along the major axis. Root of 21 is about 4.5. So as I move 4.5 units in each direction, that's about where it brings me. So that's going to be located at 0 and then plus or minus the root of 21. The eccentricity is the C value, root of 21, divided by the A value. What's the A value? 5. I'm going to actually divide that out. I know my answer should be between 0 and 1. If it's not between 0 and 1, I did something incorrect. So I take square root of 21, parentheses, and divide that by 5. And I get 0.92. So you can see that this is a fairly stretched, fairly stretched ellipse in the vertical direction. The larger value is under y. That makes it stretch vertically. If it weren't for the boys in this class, we'd fall apart. We would fall apart. Maya, stay under control. Rachel, keep it together. Carissa, focus for once. Okay. Please look at the next example. Anybody have any thoughts here where to start? Divide by 36. Thank you. It must be equal to 1. X squared over 9, y squared over 4 is equal to 1. So I have the center, I have the vertices, I have the length of the major axis, I have the length of the minor axis, I have the foci, and I have the eccentricity. Anybody want to tell me what the center is? 0, 0. It is not always 0, 0. Can somebody tell me how many units is it stretched in the x direction? 3. How about the y direction? So 1, 2, 3, 1, 2, 3, 1, 2, 3. So I go 3 units in the x direction, 2 units in the y direction. There's my ellipse. Can somebody tell me what my vertices are? The length of the major axis, minor axis, foci. How do you find C? So 9 minus 4 is 5. So what is C? Yep, C is the square root of 5. Square root of 5 is about, 2.2 or so. So if we move 2.2 units horizontally, you can see that the location of the foci are plus or minus the root of 5, 0. Eccentricity is C, which is the root of 5, divided by A. What's A? 3. And when we take the root of 5 and we divide it by 3 on our calculator, come back here. We get 0.75. So that's not as close to 1 as the last one was, and you could tell that it's not quite as stretched, is it? It's not as stretched. Not too bad, huh? One more example, we'll call it a day. Tell me something, tell me anything about letter B. It's not centered at 0, 0. I'm going to first divide through by 36. I had a good friend, Mad Dog Shy, who told me to do that once upon a time, so we're going to go again. Not doing A. Okay, here we are. Center. Vertices. Length of the major axis. Minor axis. Foci. And eccentricity. So YouTube, we digress there for a second and talk about some current issues in the world. Sure. I was not still recording. All right. A for the day. Who can tell me what the center is? -2, 1. All right. So now I want to try to decide how large to make this graph. How many units does it stretch in the x direction? 6. So if it's 6 units in the x direction, you see I'm going to go all the way back to -8, right? So I think an 8 by 8 graph would be sufficient. I'm going to go by 2s. So 2, 4, 6, 8. I was trying to trying to think of where I learned to count by 2s, and I think it was maybe by playing the game Sorry, or maybe by building with Legos, or you think of how much mathematics you learn by doing some of those games growing up. I don't think we ever had to. I think it was like, okay, you played with Legos, you know how to count by 2s. You get a 2 by 5 piece, it's 10, right? 2, 4, 6, 8, 10. Like, yeah, exactly. Legos teach you so many mathematics. All right, so there we have it. I'll put a label here just so we understand we're by 2s. And the center is -2, +1. So there I have it, -2, +1. And you said how many units in the x direction? So 2, 4, 6, I go back, and 2, 4, 6, I go forward. And so what are the locations of those vertices? 4, 1, and -8, 1. Now, do you know what people put on the test for the vertices instead of 4, 1, and negative 8, 1? They put this, plus or minus 6, 0. Because, well, yeah, they say, well, hey, it's 6, right? So that's what we did on the front side. Well, that's when the center was at 0, 0. When the center is not, that changes. And that's why I say, look at what you just put down. Like that's not at 6, that's not at 6, 0. So pay attention to what you're doing. All right, how about the y value? How many units do I move in the y direction? 2. You don't have assigned seats. You can sit wherever you want. All right, I have a horrible looking ellipse, but it's the best I could do in this moment. What is the length of the major axis? Very good, it's 12. What is the length of the minor axis? It is 4. In order to find the foci and the eccentricity, what do I have to find? How do I find C? 36 minus 4 is 32. So C is the root of 32, or 4 roots of 2. Well, I did the 4 roots of 2 on my calculator, and it came out with about 5.6. So what I'm going to do is I'm going to move 5.6 units horizontally. So 2, 4, 5.5. And it's almost all the way out to the edge here. And so the foci are going to be, you can see that the y value doesn't change, but the x value does. The x value starts at negative 2, and then you add or subtract 4 roots of 2 to it. So you go 4 roots of 2 in one direction, 4 roots of 2 in the other direction, and then the y value stays at 1. How do we determine the eccentricity? 4 roots of 2 divided by 6, or 2 roots of 2 over 3. And I'm going to go ahead on my calculator. I'm going to determine 2 roots of 2 divided by 3 because I want to make sure I come up with a value between what two numbers. Now, if I don't, I know that something's wrong. Yeah, fishy, sure. And I get 0.94. And so that's pretty close to 1. So you can see I definitely have a very stretched ellipse in this situation. Okay? What do you think? All right. Remember that the orbit of planets is often elliptical and not a circle. And so the eccentricity is something that's very much measured and determined in its shape. All right.